Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on step-up cycloconverters. So here, what do you mean by cycloconverter? Cycloconverter is a AC to AC voltage conversion device. So here, in case of AC voltage regulator, is also AC to AC conversion device. Conversion circuit, but here in case of AC voltage regulators, AC voltage controller, AC regulators, voltage regulators, there is a input frequency and output frequency is same, but here it is a frequency changer. Cycloconverter is a frequency changer, so frequency changing, so input frequency and output frequency are different, so it can change from AC power from one frequency AC to another frequency, and here this process is known as a AC to AC conversion. So here it will convert from from AC voltage to AC voltage. So here frequency is changing, either frequency is increasing or decreasing. So they are mainly used in the electric traction, AC motors, having variable speed and induction heating, cement mill drives, and next ship propulsion drives, rolling mills, and next airbus drives, next are grinding mills and mine winders. So these are the applications. So cycloconverters are used in these applications. So mainly used in the heating, traction. So here drives, we will use this cycloconverter. Main advantage, main definition is it will convert from AC to AC conversion with frequency changing. So now here there are types of cycloconverters. So depending upon the output frequency. So depending upon the output frequency, they are classified as two types: step up and step down. If output frequency is greater than input frequency, means supply frequency, that is step up cycloconverter. If output frequency is less than input frequency, that is step down cycloconverter. And next here, depending upon the supply, input supply and output supply, single phase to single phase cycloconverter, three phase to single phase cycloconverter, and three phase to three phase cycloconverter. So here in the step up there are two types. So one is bridge type and next one is a bridge type. And second one is a midpoint. And in the step down is also same, bridge type, and in this also midpoint. So these are the classifications. So first I will explain the step up, bridge type, and midpoint cycloconverter. So now here, step up and step down cycloconverter. Step up cycloconverter, here natural commutation, it gives the output voltage. Output voltage is greater than the input voltage, that is F. Here in the step down, forced commutation, and that will give F naught is less than Fs. And next here in the single phase to single phase. So here single phase to single phase. This is three phase to single phase, and this one is three phase to three phase. Three phase to single phase. So first here, this type of converter having full wave converters connected back to back. So if one converter is operating, the other one is disabled. and no current is passing through it. So this is the case for single phase to single phase cycloconverter. So in this, one is for if here this is the converter. So this is another converter connected back to back. So if one converter is operated, other converter will not be operated. That is disabled. So if it is this one is operating, this one will not be connected. And next, what about the three phase to single phase? So in this, cycloconverter operates in four quadrants, that is plus V and plus I and next plus V and plus I, first one, and next here. So all are positive. So here, so this one, next here minus V, all are negative. So that is rectifying mode. And next here one, first first current is negative here, and sometimes voltage is negative. This is the inversion mode. And next, three phase to three phase type of converter. So cycloconverter is majorly used in the AC machine systems are operating on the three phase induction machines are synchronous machines, three phase synchronous machines. So first I will explain step of uh, cycloconverter with midpoint. Midpoint. So this is the circuit diagram. This is the circuit diagram of step up cycloconverter with midpoint conversion. So now here it consists of total four thyristors. So first thyristor is a T1. So T1 at T2, T3 and T4. So here this is the P1, and next here these are the P2, and here N1 and N2. So here P1 and P2 are here P1 and P2 are positive group thyristors, and N1 and N2 are negative groups thyristors. And here one tap transformer. So now this is the, suppose this is A, this is O, and this one is a B, and this is a C. And here is the load is connected, and this is here we are giving the supply. It is center tapped transformer. So here we are giving the supply. So now here A, O and O, B, and this O and C, there is the load. Here what are the switches here? P1, P2 and N1 and N2. Now here first how it will operates. So here P1 and P2 are positive group switches, and N1 and N2 are negative group switches. So now here how it will operates. So first I will explain it. Let me change the color over here. So here is the, let me check. So now here what will happen first, uh, when supply is positive, this is the input supply we are giving. So this is the positive supply, and this one is a negative supply. So here is a positive supply, and this one is a negative VAB. So now here this is a VAB, sorry. So this is the positive supply, and this one is a negative supply. And now here what will happen first, during a positive off cycle. So during positive off cycle means what will have plus and minus, and next here plus and minus. So now here what will happen, first here, so plus terminal P1 and N2 thyristors, P1 and N2 thyristors will conduct. So first here P1 through this from A to P, and next C, and again load via, again come back to the load. So now here P1 P1 switch will conduct, P1 switch will conduct. So P1 switch will conduct, P1 switch will conduct, and after that P1 at omega equals to omega equal at T equal T1 omega t equals to T1. So P1 is forced commutation, and after that this N2 will conduct because this is negative. So now here this N2. So this negative voltage. So this N2 will conduct. So this is the N2. Let me write. This is the P1, and next here is the N2. This one. Let me change the color over here. So now here this is P1 and this one is the N1. And now here after T2 equals to, this is T2 equals to, at T2 equals to, and next here again P1 switch will conduct. So again P1 switch conduct at T3 equals to, and again N1 switch will conduct. Sorry, N2. So this is N2, P1 and N2. Again here this is the case. So here this is N2, this is P1, and here N2, and this is a P1, and again N2. N2 switch will cut. N2 switch will conduct. So now here again T3, T4. Again here during negative off cycle, again here. So next during negative off cycle here through N2 will conduct. And next here next case, so when it is positive when it is negative and this one is a positive, and P2 and N1 switches will conduct. So first here P2, I think this is here. This is P2, this is sorry P2 N1, and next to P2 this is N1, and this one is a P2, and again N1. Here this is the, here is the, and here same way here P1, P2, this is a, here is the, here is the P1. So this is the output voltage waveform. So here first P1 will P1 switch will conduct, and next N1, next P1, and next N2. So P1, N2, P1, this is N2, and again P1, again N2. Next P2, N1, P2, N1, and P2, this N1. Next cycle repeats. So here output frequency equals to 6 into Fs. So here step up transformer 6 times of, so output frequency F0 is greater than Fs. So this is the case for a step up cycloconverter with midpoint cycloconverter. So here what will happen? So total 4 switches P1, P2, and N1 and N2, P1, P2 are positive group switches and N1, N2 are negative group switches, and we are giving the supply to this center trap transformer here when VA is positive with respect to this 0 O, and now here P1 and N2, this N2 switches thyristors will conduct. So now here during negative off cycle, from the negative group N2 will conduct, from the positive group this one will conduct. So from A, P and C again load and O and again come back to the 0. So that is P1 switch will conduct. And next during from the negative group here N2 switch will conduct. So here N2 switch will conduct from the low. Here is a this is a switch N2B and load again C come back to this position. So that is N. Next at T equals T1, P1 will be forced commutation and N2 is turn on, and again N2 is turn off at T2, and again P1 will be turn on, P1 will be turn off at T3, and again T3 at T3, T2, N2 is turn on. So in this way. Same fashion here at this point P2 P2 will conduct. P2 will conduct means when it is negative and when it is positive. So during that case P2 and N1 switches will conduct. So now here in this case, so P2 will conduct. So from A P2 C and this one load and again come back to this one. This is the P2. So this is the output voltage waveform for step up cyclo converter. So now here these are the, so here output frequency is greater than input frequency. So F naught equals to 6 into Fs. So this number is depending upon the number of switching time. So this times, so here you can take 3 times. 3 times means here you will get the 6. If it is 2 times means here you will get the 4. If it is 4 means here it is 8. And now here the second one is a step up cycloconverter with bridge type. Bridge type. So in the bridge type here, what will happen? This is the AC supply. AC supply. AC supply I am giving. AC supply I am giving. So here first what will happen? So that AC supply is Vs equals to Vm sine omega t. So here what are the switches here? So how many number of switches we will use here? P1, P2, P3, P4 and N1, N2, N3 and N4. Total 8 switches. Here P1, P2, P3 and P4. So these are the positive group switches. Positive group switches. And next here N1, N2, N3, N4. These are the negative group switches. So now here this one is the positive converter and this one is the negative converter. Here these two converter, positive converter and negative converter connected back to back. So this is the bridge type cycloconverter. Previous one is the midpoint step up cycloconverter. This is a bridge type. Here we have two types of cycloconverters. So here first what will happen? So two converters, positive converter and negative converter are connected back to back. So if one converter will operate, so another converter will be disabled. If this negative converter will operate and next this positive converter will be disabled. So this is the scenario. So now here what will happen first? So during when you give the positive supply to this one, so I'm erasing this one. So now here this is. So now here, I am giving positive supply during positive off cycle. So during positive off cycle, so P1, so let me change the color over here. So P1, T1, and again load and come back to the supply. So here P1 and P2 switches will conduct. Here P1 and P2 switches will conduct. So here let me change the color over here. P1 and P2 switches will conduct. So now when P1, positive converter group switches will conduct and negative converter switches will be turned off. So now here P1 and P2 will be turned off at T1. So now here, let me change the color over here. Next, here N1 and N2. When P1 and P2 are force commutated and N1 and N2 are, so N1 and N2. N1 and N2 means here, so this is a positive supply, positive supply, positive supply, N1, N1, if in this way. So let me change if we change the color over here. So now here, this is the case. This is this one. This one. And next here is this is the case. Here P1 and N1 and N2 switches will conduct. So let me change the color over here. So this is the case. And here. So at T2 time, again this P1 and P2 will conduct. And next P1 and P2 will be forced commutation. Again this at T3, and next again N1 and N2 will be turned on. P1 and P2 will be forced commutated. And at T4, and this N1 and N2 are is forced commutation, and P1 and P2 are. So now here let me write the equation P1, P2, and here N1 and N2, and here P1 and P2, and here N1, N2. So let me write here N1 and N2. And next, during the negative half cycle, so this is the case. During the negative half cycle, what will happen? So during the negative half cycle, so this is the minus and this one is the plus. So in this case, here what will happen? In this case, what will happen? So now here this P3 and P4 switches will conduct. So here P3 and P4 switches will conduct. And now here when P3 and P4 switches, when these are forced commutation, and next N3 and N4 switches will conduct. So let me draw the circuit diagram. So this circuit is also same like this. So here, 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 again, here. See here, let me write the P1, P3, P4, and here P3, P4, and here N3, N4, N3, N4, N3, N4, and here is also N3 and N4. So this is the output waveform of this bridge type step up cycloconverter here. So first here in the if you give the negative supply, if you give the negative supply is given to this one, so now here this is the negative, so now here negative supply is given, means here, so first here P1, P4 will conduct negative, so this one, So P3 and P4 switches will conduct. P3 and P4 switches will conduct at this point, and P3 and P4 turn off, and N3 and N4. So now here N3 and N4 switches will conduct. So N3 and N4 switches will conduct. Let me change the color over here. So N3. So this is the case, and here is the N3 and N4. So next N3 and N4 will be forced commutation, and P3 and P4 will be turned on, and P3 and P4 forced commutation, and N3 and N4 will be turned on, and next again P3 and P4 and N3 and N4. Here F naught is greater than Fs, because F naught equals to 6 into Fs. So output frequency is greater than the input frequency. This is the case for step up cycloconverter bridge type. So now here these are the references. So here PS Bimbra Power Electronics book, that is Khanna Publications, and next MH Rashid book, that is Power Electronics and Circuits Devices and Applications. So that is Pearson Education India publisher, that is third edition. So these are the book, Umanand Mohan, and these are the books. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share, and subscribe. Hit the bell icon for more updates.